All right, let's dive right in. So here we have an example. Jesse has $3.02 worth of pennies and nickels saved up. The number of nickels is three more than 8 times the number of pennies. How many nickels and how many pennies does Jesse have? Okay, so let's look at this here. We're dealing with pennies and nickels. So pennies and nickels. So we're going to use um, the letter P to be the variable to represent the number of pennies, and the letter N to represent the number of nickels. So we're going to have P is equal to the number of pennies that Jesse has, and N is equal to the number of nickels that Jesse has. One thing I want to point out right off the bat here is it asks how many nickels and how many pennies does Jesse have? So what we've got now that's different than before is we have two unknowns. All right. And in order to find two unknowns, we're going to need two equations, two independent equations. So we're going to be striving to find that in this word problem. So that's an important thing to point out and to notice right off the bat, that we have two unknowns and we're going to need two equations in order to solve for those two unknowns. Okay. Now remember the formula that I gave you, T equals N times V. So N represents the number of coins. So that's the number of coins of a single value. And V is the value per coin. Oops. All right, so when it comes to number of pennies, the value of a penny is going to be 1 cent. And the value of a nickel is going to be 0.05. So notice that I've got, the variable V for both pennies and nickels, but I'm using a subscript to differentiate between these two. All right. So to calculate the total value, we're going to have the total value of pennies that's equal to the number of pennies times the value of a penny. And then here we've got the total value in nickels that's equal to the number of nickels times the value of a nickel. All right, so let's see here. Now we kind of see this relationship up here that Jesse has $3.02 worth of both pennies and nickels together. Okay, so we need to start thinking about adding pennies and nickels together. So how do we do it? So we could think of the total amount of pennies and nickels is going to be the total of pennies plus the total of nickels. And something that we know from what was given, let me say, just put, instead of no, let's put given, and that the total of pennies plus nickels equals $3.02. Okay, that was given to us up here. Okay, so far, we've been able to use the information that we've got in this first sentence. We've been able to use the information that we've got in this last sentence to tell us what we're looking for. And we're looking for two unknowns, so we need two equations for that. Now let's look at this second sentence and see what that gives us. So it says the number of nickels, or the number of nickels, n. Okay, the word is going to translate to equals 3 more than, so I'm going to think of that as plus 3, 8 times, 8 times the number of pennies. So 8 times the number of pennies is going to be 8p. So 8 times the number of pennies is p. So what we've got is the number of nickels is, so the number of nickels is, now this is what we kind of have to reverse the order here. 8 times the value or the number of pennies plus 3. So this second sentence translates to this equation here. Okay. So I think this kind of is everything that we've been given in this word problem. So looking at this initially, you might have, might not have seen all of this, but that's why we're doing this example, is to help you look for these things in these word problems. All right. So let's go about finding the number of pennies and the number of nickels. All right, so to help us figure this out, we're going to set up a table to try and organize this information and to set up relationships that we may not be able to intuitively think about. Okay, so we're going to have a table of type. And so we've got pennies and nickels. We're going to have the number of something, and then we're going to have the value of a coin. So, I mean, I should say this is the number of coins, the value of the coin, and the total value. And I'll give a subscript here. So you'll notice I've kind of written this equation T equals N times V in reverse. N times V equals T. Kind of done that over here. So let me make a table out of this. All right. So let's fill this in. So the number of pennies is this variable p, and the value of a penny is 0.01. So the total value for pennies is going to be p times 0.01, like that. The number of nickels that we have is n. The value of a nickel is 0.05. So the total value of nickels is going to be n times 0.05. So this right here is the total in pennies, and this right here is the total of nickels. So now we can go one more step. And we know that if we were to add these two together, the total in pennies and nickels should be equal to $3.02. Okay, so we've set up this table, okay, but how does this help us? Okay, you're probably asking yourself at this point. Okay, so we know that, let me get this cursor out of the way. Okay, so we know that the total of pennies plus nickels is equal to the total of pennies plus total of nickels. And let's do some substitution. So we know that this total comes out to 302. And the total in pennies is this value over here. And the total for our nickels is this value right here. So we have this amount plus this amount equals this amount. So earlier we said that we're going to need two equations. Well, this one here is our first. That's equation number one. This is equation number two. So equation number one and equation number two. So now let me go ahead and write this. Let me put this here. So we've got n equals 8p plus 3. Let me bring that down. So this is our equation number one. So now that we've got two equations with two unknowns, we should be able to use these together in order to solve for one of these variables and then the second one. So how do we do it? How do we use these two equations together? Well, notice that n, we know that n is equal to this expression. So that means in the other equation, anywhere we see an n, we can put this expression in its place. And let's see what that looks like when we actually do it. So here we've got $3.02 is equal to P times 0.01 plus, okay, I'm going to put this substituted expression in for N, 8P plus 3 times 0.05. So now we've got a new equation, a single equation with only one unknown, P. So now we've got a single equation with only one unknown. So now this is solvable. All we need to do now is apply some algebraic principles to manipulating formulas and equations in order to solve for P. So the first thing we're going to do is we're going to distribute this 0.05 to each of these terms. So let's see, let's go ahead and write down what we didn't change. So we're not changing this. This is going to be 0.01p. And then 0.05 times 8p. That's going to be 0.4p. Let me do that in black so that we can see that that came from. So 0.04p. And 0.05 times 3 is 0.15. All right, so now we've got some like terms. 0.01p and 0.04p. So we can simplify that to 0.05p. Then we have this term. And now subtract both sides by 0.15. That'll cancel out to 0. On the left-hand side, we're going to have 2.87. And that's going to be equal to I think I made a mistake here. I caught a mistake. Okay, this shouldn't be 0.04, but I caught it. It should be 0.4. And this value here should be 0.41p. Okay, I'm glad I caught it. So 2.87 should be equal to 0.41p. Divide both sides by 0.41. And the number of pennies that we've got is 7. All right, so we're able to put those two equations together in order to solve for one of our unknowns. We know we've got 7 pennies. So how do we use this now to find out how many nickels? Well, we can now drop that into equation number 1. So using equation number 1, where n is equal to 8p plus 3, we now know that p is equal to 7. So n is equal to 8 times 7 plus 3. N is equal to 56 plus 3. N is equal to 59. So what we know is that Jesse has 7 pennies and 59 nickels.